This is Geometry, Unit 9, working with Day 7, Central, Inscribed, and Circumscribed Angles. A central angle is an angle that has the vertex at the center of the circle. So FEJ would be called a central angle. The central angle and the intercepted arc, the arc that is formed by that angle, will have the same degree value. Okay, so find the measure of the following angles or the arcs in circle E. We do know that segment FE is a diameter of the circle. So you go ahead and look at some of those questions. You can pause the video, try the questions, and then come back and see how you did. When we look here at the first one, FEJ is going to be 125. The central angle touches at F and J, so it's going to be 125 degrees. JEH is the rest of the semicircle, the rest of the 180, the half a circle. Since HF is a diameter, we know that it's 180 total. So 180 minus 125 should equal 55. So that would be 55 degrees. Then when we look at arc, the measure of arc, JFG, that looks like J to F to G. That is everything. That's 360, not counting 55 or 101. So that's 360, not counting 101. So that's 259, and not counting the 55. So that's 204. So that would be 204 all the way to there, because we're not going to count the 101 and the 55 for the total of 360.
I thought a better minute. 360 plus the added total that we, and now.
So looking at the measure of GEF.
That was what I just stated.
That's going to be everything but the 360, everything but those values that we're aware of. Good job. So we have our 360 minus our 101, which is 259, minus the 50, or actually minus the whole 180. That's going to be what's left there. So we get 79. Then we're looking at the measure of arc JH, and that's going to be the same as the central angle. So if the central angle that intercepts that arc is 55, we know the arc will be considered 55. And then we're looking at GHJ. Now the notation doesn't seem right here. GHJ, that is less than 180. So we should really just have 2 letters there. That's come up a couple times incorrectly. We should only have 2 letters if we're looking at an arc value that is less than 180. So that's 101 plus the 55. So that's 156. Now we have a new type of angle we're dealing with. Take a look at what's happening here. All right, it's like pulling a rubber band back. As you pull that rubber band back, it gets tighter and tighter. It's going to get more, the angle is going to get smaller. So an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So there's your angle. The sides of the angle are chords. But the vertex is on the edge. The vertex is not at the center. The measure of an inscribed angle is half the measure of the intercepted arc. Okay, so if you know what this arc is out here, the angle is going to be half that amount. So in this case, the measure of ADB is going to be half the measure of arc AB. So that means we're going to come down to these practice problems. And we're looking at the measurement of GHJ. So we're looking at just this value right there. Okay, the first thing you want to notice is that the vertex is not at the center of the circle. It's at the edge of the circle. And it comes out and it touches G and J, and that's measurement, angle measurement is 100 degrees. So the angle is going to be half 100 degrees. So we have 50 degrees for the angle. Now, if we come over here and we looked at the angle is 40, and we're trying to figure out what the arc is, we have to remember that the measurement of angle CBD is going to equal half the measurement of the arc. Well, if you have 40 for the angle, the measurement of the arc, you're going to have to multiply by 2. So the arc is going to have to be 80. It's going to be double the inscribed angle. The inscribed angle is half the arc. The arc is double the angle. So we can come down to a little bit more involved figure. We have 37 here. That means it opens up and touches at QS. So that's going to be double the amount. So that's going to be 74. This arc is 60. So where the angle comes together, the vertex is on the edge. So it's going to be half that amount. That's going to be 30. I see that we have a diameter here. So if you have a diameter and part of the measurement is 74, double that amount. The rest of it has to add up to 180. Doesn't look to be drawn maybe to scale, but that would have to be 106. And if that was 60, that was, okay, 60, and what is going to make the 180? You have a semicircle on this side also. So that would be 120. So this would be one method to solving this question. Go to the picture, find everything that you can. Find all the calculations. Then you can come over to the questions and fill in the questions. That's one method to do it. Where in a lot of cases, we look at the question and then we try to determine what's the best way of coming up with that value. So S now we see is 30. And RQ, we've come up to be 106. TS was 120. QS is going to be double the 37. QSR, or actually SQR. SQR, that's half the circle. That's from the edge of the diameter to the other edge of the diameter. So that's 180. And then TSQ, that's going to be the 120 and the 74. That's going to be 194. So we'll flip the page. Now here's a rule that you start to recognize the more that you work with it, but here it is actually spelled out for us. If two inscribed angles of a circle, it's called an inscribed, not a central, but an inscribed if the vertex is on the edge, an inscribed angle. So if two inscribed angles intercept the same arc. So take a look at this. We open up this angle and it touches this arc of AB. And then we open up this angle and it intercepts the same arc. So you're going to be half of this sense of that intercepted arc. So those two measurements are going to be congruent. Those two angles are going to be congruent to each other. So the measurement of ADB is going to be congruent to ACB. And there's actually an infinite number of spots where D could be located. And it's all going to be the exact same measure. It's kind of hard to visualize that, but that would be true by the definition of an inscribed angle. So we're going to take a look at our figure here. We're going to name two pairs of congruent angles. So we know that SR is your arc. We have an angle that is opening up to it. So that would be half the amount. So I'm going to say that the measure, okay, they call it congruent. So we don't use measurement for congruent. Sorry. We're going to say that angle SPR is going to be congruent to the angle that is formed coming in this direction. Because both of those angles intercept the same arc. So that would be congruent to angle SQR. Because both angles intercept the same arc. Well, we have another arc that's sitting out here. And we have two measurements that are two angles that are opening up to that. Oh, I certainly did. Good eyes, good eyes. So we have our one squiggly line. Congruent would have two lines underneath that. That's your congruent symbol, not all that approximate stuff we've done in the past. So we have this angle, which is PSQ, is congruent to the other angle that opens up to touch edit. And that would be PRQ. So you've got to use your eyes. You can trace it out with your finger. You can trace it out with your pencil. You can trace it out with your eyes. But you really got to pay close attention to the angles that are touching at P and Q. And those two different angles are going to have the same measurement. So here we're looking at the measurement of SPR. SPR, I use my pencil to kind of trace it out. And it's going to be half of 81. So 81 divided by 2, which is going to be 40.5 degrees. Then we can look at PTQ. Well, let's see. If this angle in here is 81, that's called a central angle. So they're going to be the same measurement. And the vertical angle over here is going to be 81. So PTQ is going to be 81. Then we're looking at the measurement of PTS. PTS. It's the other side of the 81. It's whatever else is left over. So to me, that's going to add up to 180 degrees. So that's going to have to be 99. The angle right next to the 81 is going to have to be 99 because together they add up to 180. 180 minus 81 is 99, and that's how we got the 99. The measurement of PQ. PQ is going to be the same as the central angle. So the measurement, we're going to talk about length in the future. Length is something different, but a measurement is a degree value. PS is what's ever left from the 180, or it's the same as our central angle right there. So that's going to be 99 also. Then we have SPQ, which is half of our circle, which is called a semicircle. So you've got to look at each one of those values somewhat individually. Look around at the different values that you do know to help you calculate what you are looking for. So next, we have already talked about an inscribed angle. That's an angle that's on the inside of the circle. Now we're talking about a circumscribed angle, an angle that is correct outside the circle, and the sides are tangent to the circle. We know what tangent means. Tangent means it's going to come over and touch at exactly one point. Okay, there's only one way that that could lie in there. It gets a little bit more complicated when you're looking at your formula. Here we have the measurement of PTR. That's this angle T there. The angle is going to be half. Take a look at what we have. The big portion minus the small portion. It's the difference between those two divided by 2. Okay, if two tangents intersect outside a circle, then the measure of the angle formed is the difference of the measurements of the intercepted arc, is half. You gotta throw the word half in here. Is half the difference of the measure of the intercepted arc. So let's come on down and try that for size. So we have two unknowns here. We have this angle out here, which we don't know. And we have the arc way out here that we don't know. We need to know each one of those. So if this is 138 from P to R, we know the measurement of arc PR equals 138. We're going to be able to figure out that the measurement of arc PQR is going to be 360 minus the 138, 222. That seems reasonable. So now we use our formula that the measurement of angle PTR, you could get away with just calling that angle T, equals half the big arc, which is 222, minus the small arc, which is 138. So 222 minus 138, we get 4, 8, 9, 10, 11. So 84, half of 84. So the measurement of this angle T is going to be 42 degrees. Not a simple calculation there. Take a look at our steps that we had to do. First of all, we were given the 138. We had to calculate the 222. And we did that by taking the 360 and minusing the portion of the circle that we knew. Then we used our calculation saying that the circumscribed angle equals half the difference of those two measurements. So let's try it again over here. This portion is 232. That means this smaller portion inside the two tangents is going to be 360, not counting that 232. So that's going to be 128. So that portion of the arc is 128. We're missing our T here, but we'll put a T in that spot. So the measurement of angle T is going to be half the big arc, 232, minus the small arc, 128. And we get 232 minus 128. Carry our value over, we get 104. And half of 104 is going to be 52 degrees.